Let's talk about the laws of logarithms. So these three different laws are going to be used to both expand, meaning make bigger or larger, and condense logarithmic expressions. So that means make smaller. So if you have a log base a, so lowercase a, of a product ab, then that is equal to the log base a of the first factor of the product a plus log base a of the second factor b. And you can go backwards as well. So if you start off with two logs of the same base being added together, then that is the log of the product of those two things that you were originally taking logarithm of. If you take log base a of the quantity a over b, then in this case, that would be log base a of a minus log base a of b. And again, this a and this a, these are two different things. So lowercase a and capital A are not the same thing. But what this means is if you're taking the logarithm of a quotient, it's the log of the numerator minus the log of the denominator, and they both have the same base there. And again, you can go backwards. Lastly, log base a of a power, a to the c power, what you do here is you take the exponent of that power and you multiply it out in front of the logarithm. So this is equal to c times the log base a of capital A. Let's do a couple of examples together, and then your homework tonight is going to be to finish any problems on here that we don't do together. So we want to condense each of these into a single logarithm, meaning for your answer for all of these, you should only have at most one logarithm. So log base 4 of x plus log base 4 of y. I'm adding two logarithms that each have the same base. That's important. If they didn't have the same base, we wouldn't be able to do anything. But our first rule up here shows us that if you are adding two logarithms with the same base, it's the same as taking the log with that base of the product of a and b. So in this case, this would be the log base 4 of the product x times y. And you do need to put that in parentheses here. The next one, 5 times the natural log of m plus 2 times the natural log of m. So I can see that I'm adding two natural logarithms or logs with base e, but I also see that each of these are being multiplied in front by a number. So in this case, you need to think about PEMDAS or order of operations, and you need to ask yourself what comes first, addition or multiplication? And we know multiplication comes first. So I want to do 5 times the natural log of m first. So I know that multiplying by the 5 out front is the same thing as taking the natural log of m to the 5th power, right? So that number that you multiplied by out front becomes the exponent, plus the natural log of m to the 2nd power. Same thing here. This 2 becomes the exponent here. So now I'm adding powers that have the same base. These are both logs of base e. So that means this is the natural log or log of base e of m to the 5th times m squared. And we know m to the 5th times m squared is m to the 7th. So this is the natural log of m to the 7th power. Log base 5 of b minus 7 times log base 5 of w. Again, I want to take care of this multiplication first before I do the subtraction. So this is going to be log base 5 of b minus, and then this is going to be log base 5 of w to the 7th power. So that when we can go through and do this, and we do our subtraction, this is going to be log base 5 of the quantity b divided by w to the 7th power because of us subtracting two logs of the same base. The next one, if we have 1/2 times log of the quantity x plus 1, we know that this 1/2 will become the exponent to this quantity. So this is log of x plus 1 to the 1/2 power, or you could think of that as the square root of the quantity x plus 1, plus log base 10 of x cubed. So now that I've rewritten these with our exponents, I can see I'm adding two logarithms with the same base. So that means that I would take the log of basically the quantity of these two things multiplied together. So it's up to you how you want to write it. You could say x cubed times the square root of the x plus 1 quantity. You could do something like that. Or you could say this is log base 10 of the quantity x plus 1 to the 1/2 times x cubed. Anything like that, these are equivalent to each other, so that's going to work out. Now, if you have three different logarithms being added or subtracted, remember addition and subtraction are equal in terms of priority when you're doing PEMDAS. So you just go from left to right. So first thing, you want to take care of all of the multiplication. So rewriting logs of something to an exponent, and then deal with the addition and subtraction. So this would be log base 2, or I'm sorry, yeah, log base 2 of w squared minus log base 2 of x to the 5th plus log base 2 of y to the 8th. But now we want to combine these. So addition and subtraction are equally important, so I'm going to go from left to right. So the first thing I'm going to do here is log base 2 of w squared minus log base 2 of x to the 5th. And this is going to be log base 2 of, when I'm subtracting, that's going to be the quotient of w squared and x to the 5th. And then I'm adding log base 2 of y to the 8th. So since I'm adding two logarithms of the same base, I need to multiply this times this. So what we end up with is log base 2 of, if I multiply w squared over x to the 5th times y to the 8th, you're going to get w squared y to the 8th over x to the 5th. And that would be our final answer. Try this one, and we'll check it together in class tomorrow. And I want you to also try these on the bottom. In this case, you're going to condense, and then you're also going to evaluate. So for instance, log base 4 of 2 plus log base 4 of 32, since I'm adding logarithms with the same base, I can take the log base 4 of 2 times 32, or 64. And now we want to evaluate this. So we're essentially saying 4 to what power equals 64? Well, 4 squared is 16, but times another 4 is 64. So that's going to be 4 cubed. So our evaluation would give us the answer of 3. So what happens if we want to go the other way, if we want to expand the logarithms? So in each of these cases, you're starting with a single log, and you want to expand it as much as possible. So log base 2 of the product 6x, we know that that's going to involve the first rule here. So here we have our 6x that we're taking the logarithm of. So that's going to be log of 6 plus the log of x. And I think it was a base 2 there. So in this case, we would say this is log base 2 of 6 plus log base 2 of x. How about this one? Log base 5 of x cubed y to the 6th. So this is a product here. So first we can break that up, and we can say that this is log base 5 of x cubed plus, since they're being multiplied together, log base 5 of y to the 6th. But I can actually take this one step further. If we use our third rule, I notice that we have exponents here. Remember, if you're taking the logarithm of something raised to an exponent of 3, it's like multiplying that log by 3 out front. So this would be 3 times log base 5 of x plus, and over here, this would be 6 times log base 5 of y. And this would be the most expanded form that we could have there. Try this one on your own. I'm going to do number 14. For number 14, we have to deal with our power before we can deal with the multiplication, because it's log base 6 of the quantity AB squared. So I could first rewrite this, taking that exponent and rewriting it as 2 times log base 6 of AB. And then I can take log base 6 of AB, just this part here, and I know that this is log base 6 of A plus log base 6 of B. But remember, this whole thing was being multiplied by 2. So it's like it's in parentheses here, or in brackets, being multiplied by this 2. So if you were to distribute n, you could think of this as 2 times log base 6 of A plus 2 times log base 6 of B. Expanding just takes some practice, getting used to the order and things like that. Let's try a couple of these. Number 16, log base 2 of m to the 4th divided by n cubed. I see that we have division here, so this is going to be equal to log base 2 of m to the 4th minus log base 2 of n cubed. And again, use our third rule so that we can rewrite these exponents as the product of 4 times log base 2 of m minus 3 times log base 2 of n. Let's try a couple more. 17. I could see that this would be log base 5 of the product AB, because that you can always think of in a fraction that there's like parentheses around the numerator and parentheses around the denominator. So we're going to deal with the division first and make these a subtraction problem. So log base 5 of the product CD. And then now we can think of log base 5 of a product AB. Well, this is log base 5 of A plus log base 5 of B. But we are subtracting everything over here, which means we are subtracting log base 5 of C plus log base 5 of D. Because C times D here, it's going to be the addition of two logarithms. But we're subtracting all of that because you were subtracting log base 5 of CD. So that means this is really log base 5 of A plus log base 5 of B minus log base 5 of C minus log base 5 of D. Try some of these other problems. I'm not going to say that they're easy. Remember that square rooting is raising something to the 1/2 power, but I just want you to give them a shot. You should walk in with this paper completed tomorrow, and then we'll go through these to make sure if we have any questions that we answer those.